Hello everyone, welcome to Physics Corner, and we are discussing previous year questions of Kerala State Eligibility Test in Physics here. And today again I'm going to discuss a few questions from quantum mechanics. When you analyze these questions, previous year question papers, you can see that a reasonable weightage is given to this field of physics, that is quantum mechanics. So that's why I am discussing more questions from this topic. Okay, let's start. The first question: if E1 is the energy of the lowest state of a one-dimensional potential box of length A, and E2 is the energy of the lowest state when the length of the box is halved, then E2 is equal to E1, E2 is equal to E1 by 2, E2 is equal to 2E1, and E2 is equal to 4E1. Here you have to remember this equation for energy eigenvalues for a particle in a one-dimensional box. That is, En is equal to n square pi square h cut square by 2ma square. It's a simple one, right? So you can learn it by heart. Okay, so here it's given that E1 is the energy of the lowest state of a one-dimensional potential box of length A. So we can write E1 as pi square h cut square by 2 ma square. That is, when n is equal to 1, that energy value is the lowest value for that state. Okay, and it's given that E2 is the energy of the lowest state when the length of the box is halved. When A becomes A by 2, we can write E2 as ഇവിടെ കൺഫ്യൂഷൻ ആവണ്ട. E2 എന്ന് ഇടുമ്പോൾ എന്നിന് 2 കൊടുക്കുക എന്നല്ല മീനിങ്. ഇറ്റ്സ് ഓൾറെഡി ഗിവൺ ദാറ്റ് ഇറ്റ്സ് ദ ലോവസ്റ്റ് എനർജി ലെവൽ, റൈറ്റ്? സോ ലോവസ്റ്റ് എനർജി ലെവൽ ഇസ് വെൻ n is equal to 1. ഇവിടെ ഈ ഡിനോട്ട് ചെയ്തിരിക്കുന്നു E2 എന്ന് ഉള്ളൂ കേട്ടോ. അത് കൺഫ്യൂഷൻ ആവണ്ട. ഓക്കെ, അപ്പോൾ നമുക്ക് A is equal to A by 2 ആവുന്ന കേസ്, ഹാഫ് ആവുന്ന കേസ് നോക്കുകയാണെങ്കിൽ E2 is equal to pi square h cut square by 2ma into A by 2 all square. Okay, so we will get E2 as 4 pi square h cut square by 2ma square, which is we know already that E1 is equal to pi square h cut square by 2ma square. So we can substitute that into this equation, right? So E2 is equal to 4E1. Yeah, it's a final result that is given in option D. Okay, it's clear, right? Okay, next question: the spacing between the nth energy level and the next higher level in a one-dimensional potential box increases by 2n minus 1, 2n plus 1, n minus 1, and n plus 1. See, ഇത് കഴിഞ്ഞ ക്വസ്റ്റനിൽ അതേ സിറ്റുവേഷനാണ്, അതേ പ്രോബ്ലം ആണ് അല്ലേ? പാർട്ടിക്കിൾ ഇൻ എ വൺ ഡയമെൻഷണൽ ബോക്സ്. ഓക്കെ, അപ്പം nth എനർജി ലെവൽ ഐഗൻ വാല്യൂ അതിനുള്ള എക്സ്പ്രഷൻ വി നോ ദാറ്റ് En is equal to n square pi square h cut square by 2ma square, where A is the length of the box. Okay, so we can write En plus 1 as which is the energy value, eigenvalue for the next higher level, that is En plus 1 equal to n plus 1 all square pi square h cut square by 2ma square, right? Now so we can the spacing between the nth energy level and the next higher energy level is the energy difference, right? Potential box increases by difference 2n plus 1 energy levels we get times 2n plus 1 into pi square h cut square by 2ma square, eigenvalue of this state, right? This particle, right? അവിടെ ശരിക്കും പറഞ്ഞു കഴിഞ്ഞാൽ അങ്ങനെ എഴുതണം, 2n plus 1 into മിനിമം ലോവസ്റ്റ് എനർജി വാല്യൂ എന്ന് ശരിക്കും അവിടെ എഴുതണം. ചെറിയ ക്വസ്റ്റ്യനിൽ തരുമ്പോൾ ഉണ്ടാകുന്ന ചെറിയ മിസ്റ്റേക്കാണ്. എനിവേ നമുക്ക് വി ഹാവ് ഗോട്ട് ദി മീനിങ് റൈറ്റ്. 2n+1 എന്നുള്ളതാണ് അവിടെ വരിക. ഓക്കെ, അപ്പോൾ ഓപ്ഷൻ ബി. Now the next question. A particle linked to the x-axis has the wave function psi is equal to a into x between x equal to 0 and x equal to 1. Psi is equal to 0 elsewhere. The expectation value of the position, that is expectation value of x of the particle position is a square by 2, a square by 3 and a square by 4. It's a simple question. We have psi is equal to ax and we can calculate or find out the expectation value of x as integral over psi star x operating on psi dx. Okay, so here the limit is from 0 to 1 and we have a square x cube dx, right? Psi star is ax and psi is also x, so we can integrate this formula like a square into x raised to 4 by 4, limit from 0 to 1. So when we calculate, we get expectation value of x as a square by 4, right? It's given in option D. Okay, so the last question for this video is an eigenfunction of the operator d square by dx square is psi is equal to e raised to 2x. The corresponding eigenvalue is 1, 2, 4, 6. Okay, let's see. D square psi by dx square, we have to calculate that, right? D square by dx square of e raised to 2x. Just simply doing the differentiation for 2 times, right? So d by dx of 2 into e raised to 2x and the final result is 4 into e raised to 2x. That is, we have d square psi by dx square equal to 4 into psi, right? So d square dx square is the operator here which operates on the eigenfunction psi, and the eigenvalue for this eigenfunction is just 4, right? Option C is the answer. Okay, that's all for today. We will talk over other questions in next videos. Okay, thank you and prepare well.